So today we'll start a new topic on application of remote sensing in agriculture. So you have already seen that in India, the majority of the people who are working has got their employment from agriculture. So I'm also from agricultural background, and anywhere, whoever you will be talking in India, 70 to 75% people are dependent either or indirectly on agriculture. So our entire food grains or our entire day-to-day activities, entire GDP is dependent on crop. So if that's why it's important to introduce some technology, it's important to introduce instrumentation so that we can have a real understanding of the mapping of the cropping patterns of the practices and how the practices can be changed with the changing climate scenario so that we can have a maximum production, and those production can sufficiently feed our increasing population. So what are the important parameters or important findings that we'll be using out of? We'll be using the remote sensing and GIS for crop forecasting. That includes crop area estimation that will be like from Indian Council of Agricultural Research. The government of India wants to see the cropping pattern. What is the expected crop production that this year in this cropping season we are going to have? So how that can be modeled, how that can be predicted prior to its harvest. So that can be done only using some scientific based calculation that has got a accuracy that is more than 90 to 95%. And for that we use satellite remote sensing, because through that you can have a accurate assessment of the crop area estimation. As we know that each and every land use land cover categories has got a different satellite signature. So on the basis of satellite signatures we'll be identifying the different earth objects, and we can accurately map the different kinds of cropping pattern. Not only crop, the different types of crop, either that is pulses, mustard, rice, kharif, millet, sugarcane, potato, tobacco, whatever comes to your mind, it can be delineated, it can be identified using remote sensing, because you know that each and every crop has got a different leaf structure. Each and every crop has got a different chlorophyll content, and on the basis of those we'll be creating the different spectral response curve of those plantation to for those crops, so that we can identify those areas. So the first was crop area identification. The second one is crop yield forecasting. Like I've already said, like if you are going for like right now we are having a rainy season. That is, in during rainy season we plow kharif. Kharif cultivation is done during the rainy season. So we'll be seeing what kind of cultivation at different states they are performing, whether the monsoon is onset, on arrival, what is the expected yield that we are going to have. So all such kind of modeling, all such kinds of health related issue, like on the different dates we'll have a multi-temporal satellite dates of October, September, August, July, and then we'll see the development of the crop phenology. What are the stages, whether there is any crop infection, whether there is any disease infection, if it is show what kind of disease infection is there, in which parcel of land it is infected, and what are the medication that has been prescribed by the agricultural scientists to stop those disease spread. So all such kind of health monitoring system, yield forecasting, and their mapping can be easily identified and is being readily used by Indian Council of Agricultural Research and the Food Ministry of India and Forestry. Means this subject has got enormous capacity. Right now the most popular uh, I can say the job sector is crop insurance. So if you are aiming for a good package in GIS and remote sensing field nowadays, it's crop insurance. Just like if you go around and the people after doing MBA joins different multinationals like ICICI, Aviva, SBI for different kinds of loan, for different kinds of banking sector. In the same way, nowadays, each and every department of the banking centers are having the different crop insurance department. So there is an enormous requirement of the remote sensing analyst, where they will be doing the various kinds of crop modeling exercises, and they will be then handling the entire portal, and on the basis of their portal the entire compensation, the settlement will be done. So at that point of time, because there are limited number of experts who are in the field of remote sensing and GIS, so if you have got an expertise, you can fetch good salary. Like it can start from 40 to 50,000 per month. So that is a good package to start in. But the only prerequisite is not only getting a degree, but it is the knowledge that you have in the field of crop forecasting. So if you feel of doing your thesis, take crop forecasting as one of the topic of your research, so that you can have, if you want to do your job in some private organization, this is a good sector where you can frame your career, because 70% of the population is on agriculture. So you can think that this sector or the specialization or the expertise what you will be doing, or what you will be training yourself to be as a trained manpower, that cannot be absolute, because 70% of the people are still practicing agriculture. Our majority of the area is on agriculture. So it's a good profession. If you make yourself a good analyst, you can have a good salary structure. So the second option is sustainable agriculture, where you can go for cropping system analysis, you can go for crop residue assessment, site suitability for resource utilization, soil resource mapping, soil moisture estimation. Nowadays, you will be seeing that the government of India is regularly interacting with the farmers. They are providing their soil health card, where each and every farmer can see the soil condition of the land. They can send their samples, the scientist will analyze, and then they'll suggest what kind of farming practices should be done at your farmland, and that is all free of cost. So such kind of scientific knowledge, the scientific backing is there from the scientific fraternity, from the different agriculture university institutions who are working in the field of agriculture, and they are regularly creating the awareness program among the farmers related to their irrigation practices, related to their soil condition, related to their crop practices, that which crop will provide them the maximum cash. So accordingly, you will see that in many of the portion of India, especially if you go in Haryana and Punjab, and you compare those agriculturalists to those who are practicing in Uttar Pradesh, Bihar, West Bengal, you will find that the people who are farming in Punjab and Haryana has got a better socio-economic condition than the people who are practicing in other part of the country. So what is the reason like? If you'll see minutely, you will see that they are practicing through scientific way of agriculture. They are taking all the inputs from the scientists, but we generally in the northern part or the eastern parts of the country, we are generally practicing the old practices that our grandfather or father suggested us. So that is the need of the time, that each and every portion should change its farming practices according to the suggestion given by the various scientist institution from time to time. Apart from that, you'll see that our country is regularly, because you have seen that there is a climate change all around, so that climate change has created at the extremes in disasters. Whether you talk about drought, whether you talk about flood, you'll find extreme evidence or incidents being happening in each and every year. You'll right now you'll see Bihar totally flood up, UP, West Bengal, Assam, and various other parts of the country. And when it comes to summer, the same area is facing drought condition. So that is important uh, to monitor both the disasters. And for that, you need a technology, a technique where the remote sensing and GIS is used to identify or to product or to suggest the different kinds of a drought. Like it's whether you're going to have a meteorological drought, whether you are going to have a hydrological drought, whether you are going to have a socio-economical drought. So such kind of analysis can be easily be done using remote sensing and GIS technique. Apart from that, nowadays, because there is a crop insurance, therefore the farmer claims in case there is a disaster, and for that you need a technology who can settle, who can satisfy, who can provide the scientific justification of either you are allowing that insurer to release the money, or you are denying that farmer that we cannot pay you up, and the basis for not paying is that your agriculture was not destroyed by flood. So how you are going to evaluate that in case right now there is a flood in Bihar, which are the agricultural land which has been totally submerged, which area is untouched? Because each and every farmer who is belonging or who is not related to that tehsil or block or that village will make a settlement related to their crop insurance. They'll make a claim. So in order to deny that claim, you must have a scientific justification. At that point of time, the remote sensing and GIS helps you to identify the areas which was severely affected. Apart from that, we can also do various kinds of pest and disease impact assessment studies. Then agriculture vis-a-vis climate change. Then I've already stated, I have said. Then at large compliance research like farming system characterization, fishery, watershed development and monitoring that we are regularly studying. And finally, wasteland mapping. So it's important to study that whenever you are going for crop yield estimation or crop yield modeling, you must model the crop yield. Model describes the plant growth with the help of a mathematical equation, either a simple equation or a set of equations using the factors of production, like what is the atmosphere, what is the solar radiation, what is the day length, what is carbon dioxide, what is the temperature, what is the rainfall, wind speed, humidity. Because the crop production or the crop yield depends on these factors, where you have to identify the crop or the crop growth processes. What is the photosynthesis, what is the respiration, transpiration, partitioning of C and N assimilates to root, leaf, stem, storage. What are the various kinds of weed, pest, and disease infection? So you can see this is the crop phenology, where you have to see not only this crop phenology, what are the different day, when is the establishment date, when will be the tiltering, when will be the head of the development, and the number of days that is required, then follow flowering, then yield formation, and finally ripening. So these are the various stages through which any crop production or crop has to grow. Just like we human being, we have got different stages like child stage, uh, then you have got mature stage, old stage. In the same way, in crop also you have got various stages. So remote sensing and GIS helps you to identify whether the crop production what we have cultivated, it is as per expectation, or we are lacking it. So that lacking can be because of the soil texture, structure, fertility, moisture content, pH, EC value. So all this soil health information is as equally important as the crop growth production, irrigation production. Because the crop cannot be grown without water, so you need sufficient amount of water in and around your agricultural land. So how does remote sensing and GIS helps you to identify? This helps you to identify by synoptic overview of crop growth and temporal domain, like what is pre-harvest condition, what is post-harvest condition, what is during harvest condition, and we can provide an inputs for our simulation models at a spatial scale for large area yield production at any point of time. And using the multi-scale modeling, it is possible to identify the different crop growth at different dates at different scale, and finally we can have a final output where we can suggest to the district administration using the help of GIS whether the crop production that we have done in the current year is as per prediction or it is beyond the prediction. So the crop yield prediction through remote sensing, first we'll be developing some empirical models using remote sensing and GIS. The generally the models that we are using in remote sensing are vegetation indices. Whether you talk about NDVI, that is the most popular indices that the farmers or the governments are regularly creating for different kinds of health and crop growth modeling for vegetation analysis. Then you have got spectral profile characteristics of the crop growth. Like I was one of my friends says that he was given 2 crores of rupees for a project for creating the NDVI map of the entire country. So I said, "Ki, what was the expected time that you took to create that NDVI map?" So he said it was 1 month. So you can feel that we are a remote sensing scientist, and what is the expected time that it requires to create a NDVI map. Then you can see that a large amount of money is spent for creation of those models. And if you are a remote sensing and GIS expert, you can feel like it is not a big deal. So you can easily create a job, or you can create be an entrepreneur where you can take different government projects for suggesting the practices for modeling and providing the spectral response curves of the different crop growth prediction. As an expert, you see, the reason for being unemployed in India is that generally the students who are pursuing the courses doesn't have any professional degree. So if they go to a private organization and they demand for their employability, they'll say what skills you have. But if you are a remote sensing and GIS personnel, you will be finding that the job skills, the software skill that is required for creating such indices or modeling is you have learned during your master's degree. So once you complete your degree, you will be a great asset to the organization or to the company, which not only sees about the vegetation indices but also creates spectral profile as well as agrometeorological parameters from remotely sensed data. Agrometeorological means we have already stated what is the solar radiation, what is the precipitation, what is the soil moisture, what is the water table. So all such parameters will be used from the secondary data and will be converted so that it can be correlated with the crop yield estimation. Finally, assembling of remote sensing data in crop simulation model. So there will be assembling both the parameters, whether you say about biophysical parameters or agrometeorological parameters, all will be taken into consideration to finally create a semi-physical model. So you can see that during the spectral response curve of the various vegetation type, whether you talk about bare soil, whether you talk about soya bean at the early stage or late stage, wheat production, conifer forest production. So you see that each and every forest type, each and every plantation type, each and every crop behave differently in different spectral response uh, curve. Their pattern is different, their band reflectance is different in different dates over different bands, and will be identifying those signatures for identification of different kinds of agriculture practices. So generally that vegetation indices that we are generally using for creation of this crop forecasting is NDVI that I have already stated, which uses the formula NIR minus R by NIR plus R. This we have already done, so I'll be not going into the much detail, and that is used for creation of intercepted vegetation cover. Then you have got ratio modeling, whether you will be going for the biomass estimation, leaf area index cultivation. Then you have got a perpendicular vegetation index, where you will be going for leaf area index calculation. Then you have got weighted difference vegetation index. Against this is used for leaf area index. Soil adjusted vegetation index, that is also known as SAVI. This indices is also used for creation of leaf area index. Then you have got enhanced vegetation index, where we'll be using this all formulas. We'll be doing the practicals in our laboratories, so as to have a basic understanding कि how this model works, what are the final outputs, what are the parameters that has to be dealt with during the creation of those models. So you can see this is a multivariate empirical models, where technology, the formula that is important to identify any crop yield estimation or crop form forecasting, will be taking out NDVI, will be taking from NDVI, will be getting the growth indicators. From LST, land surface temperature, will be getting the indicators for temperature stress, and for the soil moisture, will be getting the water stress indicator. So all these studies will be taken into the consideration for creating of various agricultural models for creating of the yield prediction, and finally we'll be correlating it, and we'll be seeing that what is the accuracy of the data what we have suggested. And finally you will see that there is a very strong correlation between the various models that we have created, and that can be used as a study for creation of the various spectral response curve over the different growth. And you can see that there is a very strong correlation between this trend line. So finally, when you're correlating all this into your regression models, you will be coming up with the crop statistics, whether you talk about as a district level or a block level or a village level, where you will be predicting about the various yield estimation. You will be forecasting, you will be taking the weather data sets from the IMD satellite images, and the secondary data will be correlated with your primary data in order to create a block level, village level, district level, state level prediction. So generally the issues when you are going for the large scale forecasting is the calibration is required for each year. Models are site specific, and hence many models has to be developed for a larger region. These are some of the demerits that we are suggesting, and the philological basis of estimation could not be explained. So you can see that the government of India is regularly using the remote sensing data, where on the basis of the weather forecasting data, we can see what are the weather conditions in India, what is the soil condition, what are the soil factors, what are the leaf area index, phenological map, and finally all such informations are combined together to create a yield map. And on the basis of this yield map, any administrator or a scientist or a government department can see what kind of vegetation for the current season we can expect. So when you are going for any crop forecasting or crop modeling, there are three stages through which your data has to be constructed. The first is input. Input data is the weather data, whether you talk about rainfall, whether you talk about temperature or radiance. That are important parameters, because the entire cropping patterns or the crop depends on the these parameters. Apart from this, the soil parameters are equally important, because each and every soil in India, each and every geographical area has got a different soil texture, depth, soil moisture, soil fertility, and according to that you have to frame, you have to choose a crop that can have a good cropping production. And for cropping production you must have to see the phenology, the physiology, the morphology, and all such parameters will be modeled together finally for the management, either it is for irrigation management or whether you are going for fertilizer management. Once you have created all these data set in GIS platform, now you will be going for the modeling. So you will be processing the data sets, you will be seeing what is the phenological development that is occurring in any area. Thereafter, you will be seeing the CO2 assimilation, transpiration, respiration, partitioning, dry matter formation, all such processes. The models will be taken into consideration, and finally, after doing all this modeling, finally you'll get a output related to what is the biomass that is expected, what is the yield, what is the leaf area index, what are the water intake that is required, what is the nitrogen intake that is required. And finally, using the different algorithms in ArcGIS and in different softwares, you can create a spatial weather forecasting data where we can say about the various weather transformation, whether what is the condition in this data sets, and all the data sets will be combined together to create a grid wise weather data. So you can see that after creating all the layouts in GIS, we can see what are the different of soil classes in India, and you can see at which part you are located. And by seeing the color is representing the different soil classes, and anybody, a layman, can see and can understand that what kind of cropping pattern is required in that particular area. And once you have created that, you will be creating the different models, and on the basis of those models you will be going for your yield estimation. You will be calibrating the data sets so as to have a real understanding of the data, where you will be saying about the spatial data, whether it is related to weather, whether it is related to crop, whether it is related to soil or the sowing date. All will be modeled in different softwares to create a yield production. So the parameters generally we are using from the crop yield production or crop yield estimation is agrometeorological parameters. Agrometeorological parameters means the meteorological parameters that are related to agriculture. So those are insolation, land surface temperature, rainfall, actual evapotranspiration, then potential evapotranspiration, soil moisture, and the biophysical parameters, leaf area index, chlorophyll content, nitrogen content. And that is very important that you can see that the data sets that is required for our crop yield forecasting or production requires a diversified data set. Only on the basis of rainfall you cannot say whether what kind of prediction you can get in any area. So as at least right now you can see that we have taken at least 10 layers for creation of this crop yield forecasting, and GIS help you. Using the overlay analysis, we can perform all such exercises, and we can say about what are the crop distribution in any area and what are the crop phenology in that area. So you can see that how beautifully remote sensing can use the primary data, that is satellite images, and the secondary data into a common periphery, and all can be accumulated together to create a crop distribution or a phenological map. So you can see this is the map showing the different kinds of insulation data, ki what is the kind of ground temperature, what we are going to have during day, during night, and on the basis of that you can see ki what kind of yield estimation that you can have for any particular season, whether you are going for a biomass study or leaf area calculation, all such data sets, all such information can be obtained using the satellite remote sensing. So you can see, if you want to see the rainfall variation, what is the rainfall variation over the different parts of the country, which are the classes, which are the area which are going to get heavy rainfall, which are the area which are going to have low rainfall, which are the area getting high rainfalls. So all such information can be easily predicted before any cropping. So that is the biggest advantage that we have, that we can think about the future before it has occurred. So that is the beauty that the remote sensing and GIS gives you, where you can identify and you can see the kind of distribution that using this green color is the white cropped area, and this color is representative of the different cropping of wheat in at least 6 to 7 states. So if I said that if you go into the field and you do such kind of exercises with the measurement, it is next to impossible. But using the remote sensing and GIS data set, you can see that a large area can be easily mapped, can easily be modeled, and a real estimation, prediction, forecasting, modeling, yield, production can be easily suggested, whether that you're talking about wheat production, whether you're talking about mustard production, and the government and the administrator can easily model it. Then you have got leaf area index generation. So on the basis of leaf area index, you can see about the crop health, crop phenology can be seen, can be verified. And finally, you can use the multi-temporal data sets of different NDVI, that is from 25 October to 15 December. And then we have created the wheat NDVI. On the basis of wheat, you have wheat production, you can you can classify it, and then you can overlay with the different district boundary, state boundary, block boundary, to see as ki what is the condition of the different kind of agricultural practices that has happened over the different periods. Means what was it is from 23rd November to 15 November, then 8 December to 30 November, 16 December to 8. So all the stages can be easily modeled, can be easily mapped, and at a regional level, you can have a real understanding ki what are the different kinds of cropping pattern that has happened, whether the plantation, whether the growth that is expected in any area, whether we are having at per that or it is beyond that. So, five methods for remote sensing data integration into the model. The first one is direct use of deriving variables stated from RS data in the model. Then the forcing strategy, which suggests that the updating of state variables of the models using the LAI derived from remote sensing data. Then it requires recalibration of the model, that is the adjustment of the model parameters to obtain a simulation in agreement with the remotely sensed derived observation. And finally, the corrective methods, where we establish a relationship is developed between the errors in some intermediate variables as estimated from the remote sensing measurements, and an error in the field yield. The relationship may be applied to case in the field is not known. So we'll be using all such parameters for seeing the factors which are governing. So you can see that before we have done, during, after, all the stages of emergency can be easily monitored over the different dates, over the different leaf area index, and we can see what is the condition in that area. And finally, in the form of map, where the maps will be suggesting about the what is the kind of a ton of production that we are going to have. So you can have, you can see the, by seeing the color, we have representing the agricultural land that which is going to have more than 2 tons per hectare, then 2 to 3 tons per hectare, 3 to 4 tons per hectare, or more than 4 tons hectares. So all such data sets can be done on the basis of interpolated weather data, calibration of the crop coefficient, then sowing date from the remote sensing data, and finally on the basis of leaf area index from the remote sensing data, that is your satellite imageries. So the kind of issues or the challenges that we face for this kind of calibration or the remote sensing modeling, one is intensive input data is required for simulating each of the plant phenological process, because each and every crop has got a different phenological cycle. So it's very important to identify. It's also very important to see the historical changes in the crop health. Then a scaling of point-based crop models, use of satellite data in model calibrated with the ground data, because in remote sensing based analysis, whatever we are suggesting, it is very important to have a ground verification, because when you are going for crop yield estimation or crop acreage estimation or crop production, if you are going to forecast, you require the intensive field data to calibration for finding the accuracy, for providing the input data for different source at different scales. Some semi-physical models that are used for satellite image is the basis on the basis of which the biomass is a function of the total photosynthetically active radiation, that is power, and the ability of the plant to absorb this radiation to convert the radiation to dry matter, and the yield is a function of the net dry matter and harvest index of a crop. So the remote sensing data provides you easy for computation, less data intensive. Major factors of the crop growth depends on the radiation and the ability of the crop to convert the absorbed radiation into the dry matters, and are physically derived and used for estimating the yield. These factors are derived from remote sensing, and has this can be used for periodical and spatial availability of the input data. And finally, we can use these data sets for different kinds of models. So you can see that using the remote sensing and GIS data on the basis of the temperature data, we can see what are the different kinds of temperature, when was the temperature maximum, minimum, NDVI, insolation, then FR, reflectance, then crop masking will be done, and finally we'll be going for different kinds of yield production. So on the basis of that, we can say which are the states which are growing wheat, which are the states which are growing mustard, what are the biomass yield, what is the different yield that we are going to generate over the different dates that we have already stated. Then estimation of water scalar. So on the basis of the various gravity satellites, we can suggest, we can create a land surface water index, land surface temperature index, water index, NDVI, NDWI, normalized difference vegetation index. More then you have got MNDWI, modified normalized water index. All those indexes will be taken into consideration to provide or to create a map, where on the basis of those maps you can identify which are the area which are under tremendous water stress, and then we can suggest some alternatives, or we can have a alternative measurements for creation of those temperature stresses, where each and every part of the country can be easily monitored. We can say that on the basis of the temperature, which are the states which are going to have drought like condition on the basis of temperature. So such studies can be easily monitored, is easily monitored, is easily done using the remote sensing and GIS technique. So you can see the inputs for predicting the single date semi variables, where we are going for the water stress. We can see which are the area, if you are Rajasthan, UP, Bihar, Madhya Pradesh, Haryana, Punjab. So all such parameters will be calculated, and then it can be either at a state boundary, it can be at a village boundary, it can be at a block boundary, and you can see the kind of vegetation that is going to be created, or what is the future agriculture or what is the production that we are going to have in the current seasons can be easily monitored, can be easily monitored. So we can have a spatial database on the basis of state. You can see the what is the condition in Rajasthan, Gujarat, Madhya Pradesh, Uttar Pradesh, Haryana, West Bengal, and what are the kind of yield that is going to be expected in tons per hectare. So you can see that for different state, on the basis of remote sensing and GIS study, we can identify, we can predict which are the states which are going to have a bumper production, which are the states which are under stresses. And not only for the wheat production, we can also go for different kinds of sugarcane productions. And this sugarcane is finally used for sugar, jaggeries, baggages, and they are important energy for ethanol. And district and state level sugarcane yield forecasting is required by Ministry of Agriculture and National Federation of Sugar Mill Association. So the challenges when you're going or using the remote sensing data in India, the growth rate of sugarcane varies from 12 months to 18 months, which makes it different to generate the growth influencing inputs throughout the growth period. The cultivation of ratoon crops after the main crop poses more difficulty to generate the precise planting and the harvest days, as well as the mixing of ratoon and the fresh planted crops yield provide errors in assigning the phenological matrices. So, on the basis of remote sensing and GIS sugarcane yield estimation, we can create a, as sugarcane is a high biomass crop and the economical yield is the weight of the stem, the final yield is influenced by the greenness and the water use of the crop. So those parameters can be modeled using remote sensing based information, where we'll be creating the different greenness using the spectral index. Then we'll be creating the NDVI, that is important for getting the influencing factors, that is based on agrometeorological parameters for the water use, and the cropping pattern is linked with the evapotranspiration and the rainfall. So you can see that how the remote sensing data is used for different kinds of studies, like sugarcane classified image derived from AWIPS with a special resolution of 56 meter resolution once is a season, that is being used by MNCFC. So you can see different data, whether you talk about modis data, whether you talk about INSAT, NOAA, all such data are used for prediction of climatic model, for the creation of various moisture content. And on the basis of all these data sets, you can see that different kinds of models are created, where we are creating NDVI, evapotranspiration based on inset data, rainfall inset data, par inset data, and all this sugarcane mask area, the exact agriculture area where the sugarcane plantation is done. All such parameters will be overlaid together in the remote sensing GIS platform to create a NDVA cover of sugarcane area. Then for FR over sugarcane, then evapotranspiration, rainfall, and finally we'll be creating a model, where we'll be creating this model will be correlating with the field data sets, will be validating our data sets, will be evaluating our best model, so as to create the best model where we can have a spatial map of that area. So you can see that using this data sets, you can see what are the correlation of sugarcane yield with the agrometeorological parameters, what are the growth stage, when you are going to be highest correlations were observed for the growth during July to September, and used as a variable for yield estimation. So you can see how over the different weeks the growth are there, and you can correlate with your model. So you can see that once we have done that, again the data sets at a village level, at a state level, will be overlaid together to create a yield prediction map. And on the basis of that, you can see that what is the total amount of yield production, that is 70% for all the states. Out of 22, 18 has deviation less than 10%. So you can see that the data that is important for doing such kind of data sets are ground based data sets, that is spectroradiometer. Then ground measurement is important, and for that the different agriculture university will help you out for different cropping condition. Will be creating those spectral response curve. You will be modeling it, and finally you will be correlating it with the different models so as to see the spectral response curve with its limitation. So you can see that this is a satellite images where we are seeing the different kinds of agriculture practices that are being done, and on the basis of these practices the color, the shape, size, tone, texture association element will be identifying the different cropping patterns, their stages, and finally will suggest what is the total amount of agriculture that is predicted or that is estimated in those area. Not only the remote sensing data sets pertaining to the optical data set, but also we are readily using the hyperspectral and the microwave data sets for creation of this forest or a crop yield estimation. So you can see that how with the increase in the resolution of the data sets, with coming of new satellite sensors, with the introduce of new models, with new satellite images, you can have more detailed, more accurate data pertaining to the various cropping patterns, whether you're going in any particular crop, and the government of India can frame accordingly and can act accordingly. And with this, I'll end my today's presentation.